Hello everybody and welcome to my channel. Today we will be talking about the big three constant acceleration motion formulas. So constant acceleration, if you look back at my previous video, is either where an object is free falling or the acceleration is given. Now, if you are in an AP Physics class, you will know the big five of constant acceleration. The big five of constant acceleration I think is not exactly that useful, since you could just short it down to three essential formulas. One of them is a simple relationship between position, velocity, and time, which sort of makes sense, but you can just intuitively figure it out. The second one can just be easily figured out by plugging in some of the other equations. So the only three essential equations are the big three that I'm going to show you over here. What happens over here is we have the first of our formulas is going to be related to the final velocity. V of f is going to be equal to v of 0 acceleration times time. The second formula is this final velocity squared is equal to v0 squared plus 2ax, where x is the distance or position. Then the final formula is the position is equal to the initial position, x0, plus v0 times time, plus 1/2 of acceleration times time squared. If one knew calculus, and if one was in an AP Physics C class, one could actually derive these formulas from the basic definitions of the derivative. But we are not going to do that over here. What we are going to do is I'm going to show you one quick example showing you how these formulas can be used in conjunction. Let's say we have an object that's free falling. So this object that's free falling, what's going to happen to it is it's going to undergo constant acceleration, or g. Now, assuming that the bottom is very, very far away, so you don't have to worry about it hitting the ground, how far would it have traveled if the final velocity at that position was v is equal to 50 meters per second? Now assume gravitational acceleration 10 meters per second. What's next? Our final velocity, and it's released from rest. So v0 is equal to 0. Number one, I want you to figure out how long does it take to get to this position and what the position is. So basically, how far has it fell? So let's get started. What we need to do is a pretty simple process. The first thing is we need to find out time, and we're given initial velocity, acceleration in the form of gravity, and the final velocity. So we can plug that into our first expression. So we have Vf, or 50 meters per second, or we can just say 50, is equal to 0 plus at, or so gravitational acceleration, 10 multiplied by t. What happens is 50 is equal to 10t, and that means t is equal to 5 seconds. Now the next thing that we need to do is, using that, we'll find the position. Now we could substitute initial velocity, final velocity in this expression, the middle expression, or we could substitute it in the final expression. So maybe we can call this expression 1, expression 2, and expression 3, or sorry, equation 3, just for easy reference for this video, and we might start using it in future videos also. So we're gonna use number 2 for this one, but you could also use number 3 just as easily. So what we have here is Vf squared, so 50 squared is equal to V0 squared, so 0 2 times acceleration, which is 10 times x. So this is going to be equal to 2500 20x. So after that, we have 250 is equal to 2x is equal to 125 meters. And that's actually a lot considering it's just 5 seconds, but that's how acceleration can really add up. That's how our first problem goes. Let's do orange. So there we pull up orange. what we can do is we can figure out a new problem too. Alright, so I've switched to a different color over here, and what we can do is we can create a new problem. Let's draw this about to the left. So let's say we have gravitational acceleration going downwards, constant acceleration of g. So then what we know is we have acceleration is equal to 10 meters per second square. What we need to find out is our final velocity, and then what also we are given is we're given the fact that our initial velocity is equal to 10 meters per second. Initial velocity equal to 10 meters per second, and the distance covered is equal to 100. Sorry, no, not 100. Why don't we have 1,000 meters, or it fell an entire kilometer? We need to find final velocity given acceleration, initial velocity, and the distance. Now for me, I'm obviously looking at equation number 2 since it's very straightforward to find it from there. So we have Vf squared is equal to V0 squared, or 100, plus 2 times 10 multiplied by x, or 1,000 over here. So this, after that, what happens is this becomes Vf squared is equal to 20,000 over here, 20,000, so 20,100, and Vf is equal to the square root of 20,100, or Vf is equal to 10 times the square root of 201, and 201 itself can be factored into, if we divide by 3, if we divide by 3 over here, that's going to be equal to 6. 6 times 6, 7. Of course, guys, don't get it wrong. 6, 7, it is a meme, but just not on this channel so far. Maybe I'll include it in future videos. But that's about all we can factor it. So it's the final velocity is equal to 10 times the square root of 201 meters per second. So I really think that's about it for all our formulas, and that should be good. I think you have a solid understanding of what this is, so that should be pretty good. See you in the next one, and bye-bye.